In this video, we're learning how to verify or prove trig identities. And in order to understand this video, you guys should have a basic knowledge of some common trig identities. So if you don't already know some trig identities, I encourage you to learn those first. And if you do know them and you just need a reminder, we have linked a PDF of a bunch of different trig identities in the description of this video. So go ahead and download that and you can reference it as we are working through these problems. So now let's jump into example 1. So example 1 is the cotangent of theta over the cosecant of theta is equal to the cosine of theta. And what we're trying to do is prove that this is true. And on the right side of our screen, you're going to see some tips for proving or verifying these trig identities or trig equations. So tip one is to work on the more complex side. So typically you only want to work on one side of the equation. Some teachers or some methods allow you to work on both sides, but for the sake of this video, I'm going to just work on one side of my equation. So that means I want to manipulate one side of my equation to get it to look like the other side. Because the left side is more complicated than the right side, because it has two trig identities, I'm going to work on the left side and try and turn it into the right side. So I'm going to try and turn cotangent of theta over cosecant of theta into cosine of theta. Now, tip 2 is to change everything into sine and cosine because it is easier to deal with sine and cosine. So that's what we're going to do for this problem. So what we have to remember is that cotangent is equal to cosine over sine. So this is one of those identities that you should be familiar with before working through these problems. So cotangent is the same as cosine of theta over sine of theta. So I've changed the numerator to cosine of theta over sine of theta. And cosecant of theta is the reciprocal of sine. So we can rewrite it as 1 over sine theta. And we're going to keep the right side the same. Now, tip 3 is to look out for Pythagorean identities, which involve the trig identities squared. So we don't have any of those in this problem because we don't have anything squared. Tip 4 is to combine fractions using common denominators. We have a fraction within a fraction on our left side, so we're not going to combine, we can't combine them with common denominator. We can't do step 5 or step 6 right now, but I will show you guys those in some of the future problems. So what we want to do on the left side here is anytime you have a fraction within a fraction, you probably want to simplify that. So remember that a fraction bar is the same as division. So what this is really saying is this numerator divided by this denominator. So I'm going to write it like that. So we can write this as the cosine of theta over the sine of theta divided by 1 over sine theta is equal to cosine of theta. And now remember, to divide fractions, you want to keep change flips. You're going to keep the first fraction the same, and you are going to multiply by the reciprocal, or the flipped version of the second fraction. And now you guys can probably see that we can just cross out these sine thetas. We can cross cancel them, so we just are left with cosine of theta on the left side of our equation. We have cosine of theta on the right side of our equation, so we are finished proving this identity. Let's work through some more examples. So for the next examples, we're not going to have these tips on the right side of the screen just so that I have more space to write. So if you want to go back and write down those tips on your paper, I encourage you guys to do that because I will be referencing them throughout the video. So example 2 is tan squared x plus 1 over secant x is equal to secant x. So we want to work on the left side because it's more complex, and you can always start by changing everything to sine and cosine. So if you're struggling with verifying trig identities, you can always start that way. But I think that if you see any of the trig functions squared, you want to stop and think if you can use a Pythagorean identity. So if you go ahead and look on the reference sheet that we've linked in our description, you should see a Pythagorean identity right up here that says that the tangent squared of an angle plus 1 is equal to the secant squared of that angle. And now you may realize that that's what we have on the numerator of the left side of our equation. We have tangent squared of x plus 1. So what we want to do is rewrite that as secant squared. So we are just using the Pythagorean identity on the top right to rewrite our numerator as secant squared. And now this problem is pretty easy. We have secant squared x on the top and secant of x on the bottom. And remember, secant squared x is like secant x times itself. And now you guys can probably see that we can just cross out one of the secant squared x's on the top and bottom of this left fraction. So we get that secant of x is equal to secant of x. So that's an example of how sometimes it is faster to not change everything into sine and cosine. So my rule of thumb is if I see anything with a squared in it, I try to see if I can use my Pythagorean identities before switching everything to sine and cosine. Let's keep working through some more examples. So problem 3 is cotangent of theta plus tangent of theta equals secant theta cosecant theta. So both of these sides look just as complicated. So I would start on the left side. I typically start with anything that's being added over things that are being multiplied, because if we're adding two things together, we can turn them into one term by making a common denominator. So that's how I'm going to start, but you probably could start on the right side and figure it out as well. So for this one, let's start by changing everything into sine and cosine. So we'll start with that step. So cotangent of theta, remember, is equal to cosine of theta over sine theta. And tangent of theta is the reciprocal, so it's sine theta over cosine theta. And we're going to keep the right side as is, so secant of theta times cosecant of theta. And now, if you look at the tips that I put on the first screen, one of the tips is to combine fractions using a common denominator. So that's what we're going to do here. So we want to combine the two fractions on the left by using a common denominator. So what that means is we need to multiply the left fraction by cosine of theta over cosine of theta. So we're going to get cosine squared theta over sine theta cosine theta. And we have to multiply the right fraction by sine theta over sine theta. So we're going to get sine squared theta over sine theta cosine theta. And this is still going to be set equal to the right side of our equation. And now what we want to do is combine these two fractions on the left. So we're going to combine the numerator. So we have cosine squared theta plus sine squared theta all over our denominator of sine theta cosine theta. It's equal to secant theta cosecant of theta. And now we have a cosine squared and a sine squared, so you want to look for Pythagorean identities. And if you look on your sheet, you should see that cosine squared of something plus sine squared of that same thing is always 1. So we can rewrite the numerator as 1. And I'll put that identity up here just so you guys know which one I'm using. So that is a very important identity to know. That is like the main Pythagorean identity. So we're going to rewrite our numerator as 1. On the bottom, we still have sine theta cosine theta. On the right, we have secant theta cosecant theta. And let's continue this over here. So 1 over sine theta cosine theta is really the same as 1 over sine theta times 1 over cosine theta. We can break it up into two fractions like that, and I'll show you guys why I'm doing that. And now you guys should know the reciprocal identity, so you should know that 1 over sine theta is equal to cosecant of theta, and 1 over cosine theta is equal to secant of theta. So we've basically turned the left side into the right side. We just need to switch the order. And when we're multiplying terms, it doesn't matter what order we write them in, so we can rewrite the left side as secant theta times cosecant of theta, which is the same as our right side. So we are finished verifying this one. Let's go through a few more examples just to make sure we really understand this. So for example 4, we have 1 over 1 minus sine theta plus 1 over 1 plus sine theta is equal to 2 secant squared theta. So the left side is way more complicated than the right side, so we are going to start on that side, and we already have everything in terms of sine or cosine, so we're going to look out for Pythagorean identities. There's nothing squared on the left side, so we don't need to use that tip right now. And because we have two fractions, we want to combine them together using a common denominator. So that common denominator is just going to be each denominator multiplied together. So in order to make the left fraction have a denominator of 1 minus sine theta times 1 plus sine theta, we have to multiply the top and bottom by 1 plus sine theta. So we're going to get 1 plus sine theta over 1 minus sine theta times 1 plus sine theta. And for the right fraction, we have to multiply the top and bottom by 1 minus sine theta. So we get 1 minus sine theta over 1 minus sine theta times 1 plus sine theta. And this is going to be equal to our right side, 2 secant squared theta. And now we can put the two fractions together, so we can just add the numerators. So we have 1 plus sine theta plus 1 minus sine theta all over 1 minus sine theta times 1 plus sine theta. And we still have 2 secant squared theta on the right side. And now what we want to do is combine like terms in the numerator. So 1 plus 1 gives us 2, and then this plus sine theta minus sine theta, those cancel out to 0. So we're just left with a 2 on the top. And our denominator is 1 minus sine theta times 1 plus sine theta. And this is equal to 2 secant squared theta. And now what you want to do is kind of think about what needs to change on the left side to make it into the right side. So we have a 2 on the left side and we need a 2 on the right side, so that's good. But we've got these signs on the left side and we need to somehow turn that into a secant squared. So what we want to do is maybe FOIL out the denominator of our left side and see if it can be turned into some identity, see if we could substitute something in for it using an identity that might help us get to secant squared. So up here, we're going to go ahead and do that. So we're going to keep 2 on the top, and we are going to FOIL out this denominator, and if you do that, you will end up getting 1 minus sine squared theta. And on the right, we have 2 secant squared theta. And now we have a sine squared, so we want to think if we can use a Pythagorean identity here to change our numerator into something else. So up here, I'm going to write this Pythagorean identity that says cosine squared theta plus sine squared theta is equal to 1. And what you have to know is that you can manipulate these. So if we subtract sine squared theta from both sides, we'll get that cosine squared theta is equal to 1 minus sine squared theta. And now that looks like our denominator. So we're going to replace 1 minus sine squared theta on the left side with cosine squared theta. And now cosine is the reciprocal of secant, so cosine squared is the reciprocal of secant squared. So 2 over cosine squared theta is the same as 2 times secant squared theta. So we get that both sides of our equation are the same, so we are finished with this problem. Let's go through 2 more examples just so we have a good idea of all the different types of trig identities we could have to prove. So for this problem, we have 1 minus cosine x over sine x equals sine x over 1 plus cosine x. So neither of these sides is really more complicated than the other, so you can start on either side. Let's start on the right side because I've always been starting on the left side. So just show you guys that you can start on the right side sometimes. So we're going to keep the left side as it is. And our right side is already in terms of sine and cosine, so we don't have to use that tip. We can't do Pythagorean identities because we don't have anything squared. We can't combine fractions because we only have one fraction. So what we're going to do is multiply by what's called the conjugate. So that's tip number 5. So because we have 1 plus cosine of x in our denominator, what we're going to do is multiply our numerator and denominator by the conjugate of that. And the conjugate is going to be 1 minus cosine of x. So we're going to multiply the top and bottom of our fraction by 1 minus cosine x. We're going to keep the left side as is. I'm going to keep the numerator as is for now, and I want to multiply out the denominator to see if I can cancel anything out. And the reason I did that is because I need to end up with a 1 minus cosine x on the top of my fraction. So somehow I'm going to have to cancel out this sign in the numerator of the right side of my equation. So I want to keep it factored out so it's easier to cancel out. And then on the bottom, if you FOIL 1 plus cosine x times 1 minus cosine x, you will get 1 minus cosine squared x. Now we see something squared, so we want to look for Pythagorean identities. So if you look on your sheet, you should see this identity that says cosine squared theta plus sine squared theta is equal to 1. And remember, we can manipulate these. So we can subtract cosine squared theta from both sides to get that sine squared theta is equal to 1 minus cosine squared theta. That's very similar to what we have in our denominator on the right side of our fraction. So what we're going to do is replace 1 minus cosine squared x in our denominator with sine squared x. Keep our numerator the same. And now you guys may be able to see that you can cross out a sine of x on the top of our right side and the bottom, because we have a sine of x on the outside of the top and we've got a sine squared x, which is really sine x times sine x on the bottom. So we're going to cross out this sine x, cross out one of the sine x's on the bottom, and we get 1 minus cosine of x on the top over sine of x, which is what we want. So we are finished. Let's go through one last example. So for this problem, we have secant to the fourth x minus secant squared x equals tangent to the fourth x plus tangent squared x. Now again, you can start by changing this into sine and cosine, but that is going to take longer than using the Pythagorean identities. So because we see squareds and trig identities raised to the fourth, we probably know that it might be faster to use Pythagorean identities. Another way to tell that it may be faster to use Pythagorean identities is to actually look at your Pythagorean identities and see which trig functions go together. So I'm actually going to write them up here. So if you look on your sheet, you'll notice that tangent squared of theta plus 1 is equal to secant squared of theta. So tangent squared and secant squared go together. So because we only have secant squareds and secant to the fourth and tangent squareds and tangent to the fourth in this equation, we can probably use Pythagorean identities. So both sides are pretty complicated, so it doesn't really matter which side we start on, so I'm just going to start on the left. And what I'm going to start by doing is factoring out a secant squared x. So I'm going to pull out a secant squared x, and I'm going to be left with secant squared x minus 1, and I'm going to keep the right side as it is. So we have tangent to the fourth x plus tangent squared x. And now we want to look at this Pythagorean identity up here on the right, and we notice that we can replace secant squared x with tangent squared x plus 1. So we replace it with tangent squared x plus 1. And we still have times secant squared x minus 1. And this is equal to tangent to the fourth x plus tangent squared x. Now, if we look at the right side of our equation, we only have tangents, and on the left side, we still have this secant squared x. So we're probably going to have to change that into something that involves tangent. So if we go back up here to the top right to our Pythagorean identity, remember we can manipulate these. So if we subtract 1 from both sides of this identity, we're going to get that tangent squared theta is equal to secant squared theta minus 1. So now we can replace secant squared x minus 1 with tangent squared x. So tangent squared x plus 1 times tangent squared x. And we're going to keep the right side as is. We have tangent to the fourth x plus tangent squared x. And now we just want to distribute this tangent squared x into this first set of parentheses. So tangent squared x times itself is tangent to the fourth x, and tangent squared x times 1 is just plus tangent squared x. And now both sides of our equation look the same, so we know we're finished. So hopefully this video helped you guys understand how to verify trig identities. If you want some more practice with problems similar to the ones we worked through today, check out the link in our description for a free practice worksheet.